All right, thank you all for joining us today. We are going to do biome cycling today, but it actually gets way bigger than that. We spent 10 months on this, and I asked to share this all with you guys today because I learned a lot of stuff that I did not expect to see, and I think you guys will enjoy it. So what I'm going to hit on is the 15 things that changed the way that I look at my tank forever. And I don't use those words lightly. I really will not look at my tank the same way as I looked at it before, and hopefully you guys will say the same. If you're here, you probably already know, my name is Ryan Batchelor. I'm an 18-year reefer. Started this in like 2004. I called that my primary qualification. I've been doing this a lot. I've failed a lot. I've succeeded a lot. I've been around a lot of tanks. I got 50 plus tanks at work. I'm also the founder of Bulk Reef Supply and BRStv. So the first time I ever talked about rock was like 2008. 17,000 people or something watched that since then. Right now, my current position is customer advocate. Oops. For a place called Aperture Pet and Life, which owns Bulk Reef Supply now. Good news. That means that I no longer have to worry about whether or not we ship anything, and my sole function here is actually to do just this type of stuff that we're doing today. And I believe that all that's driven by the fact that I believe that this hobby is hard. The failure rates of it are really high. And my mission is to help reefers overcome that and realize their dreams in the same way that I have. And thank you all, because I get to do my dream job every single day because you guys are interested in furthering your tanks as well. Also, I'm doing it again. I'm going to poke the bear today. So I want to take some risks. I want to say some stuff that is uncomfortable for some people to hear, some things that challenge the things that we know. And so I'd like you guys to do that for the next hour. Let's push the limits together, open our minds to some new things that we haven't seen before. And the real reason we're here is because 3 years ago I started a journey about my first speech. By the way, this is my second speech my whole life. So if I have a nervous breakdown, you'll know why. But we started down a journey of having a 10-year tank, and it inspired me to set up my own tank. I put a lot of effort into it at my new house. It was going to be the biggest tank I ever did. And man, was that a really, really hard journey. It was filled with cyano like I had never seen before. It was filled with dinos like or diatoms like I'd never seen before. It was filled with bacterial blooms that would come, and they would come and go. One problem just going to the next. And the reality is if this can happen to me, it can happen to anybody, and I need to know how to find the solution to this so we can stop the gambles that are happening each time. So that's what this is. We're going to beat the ugly stage, the biome cycle. And for those of you wondering what the cycle is, we're not talking about nitrogen cycle anymore. Everybody in this room can do that in their sleep. In fact, you throw some fish, throw in some Dr. Tim's, and move on with your life. Cycling a tank is no longer hard. What we're talking about now is getting it ready to sustain life, getting it ready to sustain corals and fish in a healthy atmosphere where they actually thrive. And so these are all the questions, real quick. I'm going to breeze through them that we're going to hit today. It's a lot of stuff. I'm going to try to hit it inside of an hour, so I'm going to go fast, but I might go over because we're going to find out what are the uglies of the ugly stage. We're going to find out what causes these uglies. We're going to do slimes have natural predators in the same way that algae does? Why does one solution to one problem cause the direct cause of the next? Is an ounce of prevention worth a pound or versus a pound of cure? Diversity sounds good, but is it? Answer is no. Is dry, sterile rock better than wet, live rock? That's a question I think a lot of people would like to know the answer to. Can we seed the microbiome to a tank cleanly? Can we find the balance in between those two things? And is a dark cure worth the effort? A lot of people call it cooking rock, but is it worth the effort to go through doing all of that? Does dipping corals affect the microbiome? When we're dipping the corals and we're killing all the stuff that's on the rock or on the corals, are we affecting what enters our tanks? The answer is yes. What does a good biome cycle look like? What's the measure that we're going to measure to, and how can we achieve success? Is it possible to build layers of redundant protection against the uglies as well? So where if one of these things lets us down, because it's a reef tank, anything can go wrong. We can only influence an outcome, we can't guarantee it. So if that one lets us down, can the next thing catch it? And what is the number one mentality that's holding us back? There's something that a lot of us do, including myself, that's holding the whole hobby back. What can we fix it? And lastly, are we emulating a pristine ocean reef or a successful artificial ecosystem? And my mind has changed recently about that. And it's probably a blend, but there is a big difference. So the experiment that we did is we took 12 tanks. Thank you, Red Sea. They provided us a whole bunch of tanks to do this in. There's a big lab in the back, and we set up experiments. So we're going to cycle them in 12 different ways and see what we can learn from it. We have one we call the control. It's dry rock, dry sand. We're going to measure how that works. We're going to do 2 live rocks. One of them is what I'll call a paper wet, meaning it was wrapped in paper in Indonesia, sent on a boat, and 3 months later ends up at your house. Then we also have a wet live rock, which could come from either a fish store that was housing it in the fish store, or it could come from somewhere like the Gulf, where they drop the rock in the Gulf, bring it out, ship it in bags of water to your house. We also have what we call the Instacoral. I've done this one many times to various results, but I understand why now most of them were successful, but why some of them wouldn't be. Also, we have 6 of them from various aquariums. So using microbiome from an aquarium to start those tanks. Now, a lot of this, by the way, this is a 10-episode series. So I'm not going to be able to give you every last detail. A lot of it's pretty nerdy. This is the outcome. So you get to skip all 10 episodes of the nerdy stuff, but you can come and join it later if you want, because that will be uploaded pretty soon. All right. So stage 1 of this is, oops, did I miss one? Nope. Okay, so stage 1 is what we're calling the dark cure. So in stage 1, we throw rock and sand in there, we start it up, they throw a couple of clownfish in, and we leave the lights off for 4 weeks to see what develops inside the tank in terms of measurable biome, as well as what they look like. And not surprising, when the lights are out, they all look pristine like this one, because all of the uglies are photosynthetic. Every single one of them gets energy from light, so if the lights are out, they don't grow. Next thing, we're going to illuminate these tanks. So for 6 weeks, we turn them on to the LPS zone. So we're going to turn them on to 75 to 150 par, which is a lower par, lower energy zone, and see what comes up and grows and takes over our tanks. Then for 4 weeks after that, we'll turn it up into like the 350 par zone of SPS, and it's presumably, man, we're going to hit it with the sun and watch it just take off all the uglies. And some of them do, some of them don't. Then we introduce the pests. So at the end of that one, really some of these things perform better than you think, but they didn't have to deal with the pests yet. So they didn't have to. Of course, the sterile tank did well because it didn't have any source of dinos or diatoms or green algae. So I went around to all 12 of the tanks. We sucked out all the diatoms. We sucked out all of the cyano, the green algae, the chrysophytes, and golden brown algae, and we made a slurry. And we dumped them in all 12 tanks to see which of these tanks could actually defend against these things. And most importantly, can they defend about them without the reliance on snails and crabs and fish? And the answer is yes, some of them could. Most of them can't. But which ones and why and how does it connect together? But we also did it twice, by the way. I wanted to make sure they were all infected with all of these things. So we went and mixed it up again and dosed them again. All of these things are introduced to this. And then we introduced the microcrustaceans. So microcrustaceans can be a whole lot of things. It can be amphipods, tiny little snails, copepods. Notice how that tank is clean. One of the things that you're going to see today is how important that the copepods are. This is one of those things that opened my mind. I think anybody here, raise your hand if you thought copepods were important to a tank. All right, about half of you. How many of you think they're really, really important, like critical? If you didn't have them, you would have a problem. Yeah, Sean, algae barn, over there. Okay.
Anyone else?
Yeah. You're going to have a different opinion today. Guaranteed, you will not think about this the same way. There's a reason that this tank is clean now. Okay. We also did aquabiomics. Is anybody from there here? No? Okay, so aquabiomics did eDNA testing. So it's DNA testing, environmental DNA testing. So basically anything that like goes through the universe will leave some kind of trail of itself in the past. And in water, it's really good because it's fluidized and you can capture it and test for it. So we're going to do eDNA testing. We'll test for diversity. Diversity in the microbiome of archaea and bacteria. It'll test as a percentile. It says a 10 right there. That means that 90% of tanks are better than this one. And we measure against that. Short story is diversity is actually an end game, not where you start. We also test for balance. So balance score is something different, which is not how many things that you have in the tank, but are they the right things and are they in balance with each other, which turns out to be way more important than diversity. Like most things doesn't really help me. And then we look at the composition of this stuff, and I guarantee we'll get past the nerdy portion of this in just a second. But we look at what types of bacteria make up a typical tank. On the right there is a typical sample, and on your right, on the left of that is your sample. And so your sample in my brand new tank does not look anywhere near as balanced or diverse as a typical tank. All right, so moving on. What are the uglies? And there's 5 of them in my mind. There's a bunch of them that go past this, but the 5 is they're all photosynthetic, and there are 5 of them. So one of them is algae. This is probably the easiest one to beat in most cases. It's your hair algae, it's your turf algae, your bryopsis, your film algae, your bubble algae. And the main way that you would beat these things is usually some fish. So some fish, like a Zebrasomas tang or even a bristletooth tang, will eat your hair algae. Turf algae, a little bit more picky. A lot of these things, though, like the turf algae and the bryopsis, once they take over the tank, the fish aren't really interested in eating it, or they can't eat it faster than it replicates. So it's more important that we put the fish in before these things grow than it is waiting until there's this plague outbreak of bryopsis. And then specialized fish for bubble algae, like your fox-faced tang, or rabbitfish, rather. Okay, golden brown algae. Who here has heard of chrysophytes before? Okay, not very many people, but you've probably seen it in a lot of tanks. So chrysophytes are like thousands of different things, and they come in different forms. This is one of the ones that shows up in some of these tanks. It's kind of a bubbly, matted form. It looks terrible, and it covers everything really rapidly. This is probably a form that a lot of you have seen more, and you could mistake it pretty easily for like a green hair algae or something. The difference is it kind of looks bleached. It looks like it is really weak, like it's going to die. And another thing is it explodes everywhere in the tank all at once. So if it isn't green, looks like it's golden brown, and it explodes all over the tank all at once because it has a flagellum, it's mobile, and it can go everywhere in the tank, probably chrysophytes. Another one is diatoms. This is a form of diatoms here. It comes and it just shows up for a week, and then just like that, it's gone. This happened in every single one of the tanks. There's some form of diatom that shows up in here, disappears inside of a week. Other times it looks like this, takes over the entire tank, turns ugly, ugly orange-brown. We're just calling it explosive orange diatoms because it is really nasty, and guess what? It stays around for months. Nothing will make it go away or time will not make it go away, I should say. We did find solutions to it. Diatoms tend to look like this. Under the water, there are these little teeny shells. And if you look over here, they're mobile. So this little guy is slowly going underneath that bubble. This is the reason that they look like a slime in our tanks, is because they are essentially a silica shell, which is glass, and then they surround themselves in like a mucus, and when you get enough of them, they form a slime together, and there's clearly enough of them here under the microscope. Also, what are dinoflagellates? Not all that similar or dissimilar from a lot of other slimes, but you can see it growing in the sand here. In the sand, it'll form this big sheet of stuff, and we're lucky here it doesn't actually take over the tank. And who here has had battle dinoflagellates before? All right, who said they were easy to beat? Yeah, sometimes they are, sometimes they aren't. Sometimes they solve themselves. Sometimes, man, you just want to punch yourself in the face for the next 6 months. It's really, really tough. This is what they look like under the microscope. Tiny little guys shooting around everywhere. And they're little teeny creatures all over the place. And there's things eating them. If you look right here, there's a tiny little microcrustacean that comes out. There's one right here too. So look at these two places. There's little crustaceans that live in here, they eat these things. And so there's more to the eye than we see in our tanks. We see fish, we see coral, whatever, but down underneath all that, something totally different is happening. Cyanobacteria. So who has run into cyanobacteria? That's everybody. So in some form, it can show up like this sometimes, where it's just like a red mat that kind of covers up different areas, but it often looks different. Another way it can look like this is just a purple tint on the top where it kind of looks like coralline algae. but it's growing faster. And the more you see, the more disappointed you are that it isn't coralline algae. And other times, it can look like this sludge. In fact, when I saw this sludge, I wouldn't have thought that this was cyanobacteria at all, because it like sheets onto the rock. You have to like peel it off. It is a total nightmare. The reason that I know it's cyanobacteria is one, we looked at it under a microscope. It looks like this. It looks like a hairy kind of network of red strands. It's not the same thing as those little critters that are crawling around. Also, I know it worked, or that it was cyano, because red slime remover worked later on. And it does not work on dinos or other things, because you can see that these things are very different. So even though they all look like slimes, I now know why red slime remover would work on one thing, but it wouldn't work on these other bugs in the tank. All right, so what causes the uglies in the tank? Well, Terrence, you want to tell me what causes them?
Lack of diversity in the tank.
Lack of diversity in tank. Wrong answer. We do. We are the cause, right? I mean, the answer is like nobody, you couldn't pin it all on one thing, right? But knowingly or unknowingly, we influence the outcome of a great microbial or microscopic war that's happening in our tank. So every single decision that we make, whether it be when we add the corals, when we add the light, when we add the copepods, when we do anything in the tank, we're not ensuring that any single thing will happen. What we're doing is influencing the outcome of a little microscopic war that's happening in our tank that we may not know about. So timing is one of the things I just mentioned. So when we do it actually may matter a lot more. So like one of the frustrations I think we all have is we could line up 10 people that seemingly did the exact same thing, and they could have 3 totally different results amongst those 10 people. It's in the nuances and things that are real tiny changes, like, well, you know what? I started my tank, my Insta tank with LPS corals, and it was running at, I ran it dark for 4 weeks beforehand. Somebody else decided to run dark for, but they ran SPS corals right after. Well, now they're dealing with 4 times the light. It was a different outcome. Or maybe I seeded the pods 2 weeks before, or I dumped them in the day before, or I dumped them after I put the coral in which case I probably added the dinos and stuff already. So the subtle timing probably makes the differences in the nuances that count. We also have intentional, unintentional, and reckless introduction via the rock, water, and coral. None of this stuff appeared out of thin air. Did you see the dinos? Those things don't just appear out of thin air. Like there isn't a magic dino wad that like just magically appeared in the tank. We had to put them in there, right? And so there was only one of 12 tanks that got those things. So after 15 weeks, only one tank turned orange. But after we seeded it from all the other ones, almost all of them got it after that. And the ones that didn't, you'll be able to see a very distinct reason. So how do we stop the introduction? Well, dry rock, dry sand might be one of them, but we're also stopping all of the good stuff at that point too. Coral dips is another one. So if I'm dipping things in hydrogen peroxide, algae is no longer making it in my tank. Some forms will, but not all of them. So thinking about how do we stop the introduction while also balancing the introduction of the good things that are in there. There's also a lack of natural predators and competitors. The ocean has them all. Your tank only has the ones you introduce. So you're going to see this theme throughout this presentation pretty heavy. Is the ocean has every last damn pest known to man. It has the flatworms, it has little red bugs, it has the diatoms, the dinos, and every possible strain of them. But it also has the predators for all of those things as well. It has the things that prey on them, and because of that, they find balance with each other, and never one takes over the entire ocean. In this case, everybody pretty much knows you can use a purple, yellow tang and keep hair algae at bay. But that's kind of where the mentality stops for a lot of people. How do we get deeper into this and prevent all the other pests with maybe predators that you can't see? Most are photosynthetic. It's the most abundant energy source in the tank. So one of the important things to note about like dinos and cyano and diatoms is these are tiny little creatures that can replicate really fast because they're producing their own energy out of nitrogen, phosphorus, light, and water. Something like a copepod actually has to hunt around the tank and find energy and process it and digest it. It's just a way slower process, and so these guys will scavenge it much faster. And their nutrients is another way that we cause these things. And nutrients, for me, I think that it's time for this conversation to evolve a little bit, because we've all spent so much time talking about starving out all the pests. How do I starve these things out, lower nitrogen and phosphorus, to the point that this animal or plant can't possibly replicate itself anymore and dies off? Well, I got news for you. That means everything in the tank, because every living organism requires nitrogen and phosphorus to produce its DNA. So if we do that effectively for the dinos and diatoms, we're going to starve out everything else out as well. But there's a distinction between fueling and starving. That also doesn't mean I want to start my tank with 20 parts per million nitrate and 1 part per million phosphate, because that is going to produce a pretty ugly result as well. There's also a difference between today, when I start my tank, and 3 years from now. 3 years from now, I have every possible predator and prey probably in flux, or not in flux, stability with each other. And now if I get nitrate and phosphate, it's a little high, who cares? It really does. You see tons and tons of old established tanks that have high nutrient levels, but it doesn't matter because they found equilibrium. Okay, do slimes have natural predators? Today, Sean's grandchildren are going to remember this day. Okay, they do have natural predators. Okay, I went looking for information on what will eat a diatom, right? I stumbled upon Algae Barn's website that says, what do copepods feed on? Turns out they love algae and diatoms. All right, so I called up Sean, I asked him if that was really true, who wrote this thing, and he says that to culture the copepods, they actually have to dose diatoms in there. Otherwise, the copepods will stop reproducing, I think it's like the 8th cycle or something like that. It's probably the silica or some nutrient that comes with the diatoms, that if you don't put this in there, the copepods stop growing. All right, here's the problem. Is anybody their snake oil alarm going off? Anybody? Because mine does. Just because a manufacturer talks about itself great doesn't mean it's really great. But there's other information. So I go down to Monterey Bay Aquarium. I have Meet the Copepod, right? Cool fact down there in the bottom, single copepod eats 11,000 to 373,000 copepods a day. It's one. Imagine if there is thousands of them in there. All right, so this isn't Sean trying to sell his copepods anymore. This is the Monterey Bay Aquarium. All right, so now I found on YouTube this guy. His name is El Chifo. Hopefully he doesn't mind that I used his video here, because this is the best video I've ever seen of amphipods eating dinos, right? I mean, these little critters are running around the tank, chewing up these dinos. Seeing's believing. There's a bunch of these videos out there. If you go looking for them, you can actually watch these things eat them. And at different parts of this video, you can actually see them in the belly of the amphipod swimming around trying to actually get out of the belly. All right, anybody question whether or not microcrustaceans eat dinos at this point? Okay, well, no, but the real question is, can it solve my dino problem in the tank? The answer is yes. All right, week 25. Okay, so this is a tank that is overrun with diatoms. Has anybody seen a problem like this bad before? Okay, I mean, you keep getting nods out of you. You must have had a really terrible tank at one point. Me and you feel each other. Okay, so this looks terrible. It is super hard to beat. Okay, so we add some copepods. Call up Algae Barn and say, send me some copepods. I add them to the tank. In 1 week, turns to sludge. All of the copepods eat the diatoms, process it into waste, if it plays, process it into a waste, and this tank looks orange for months. And then out of nowhere, all of a sudden, processes it into this sludge that's in the tank. We clean the sludge out, diatoms never come back, right? So you're wondering, well, maybe is that just that one tank? The answer is no, it was all of them. So even this one, it's got cyano and diatoms in it. Same thing happens, processes it into sludge. We clean it out of the tank. And while this tank's got other problems, man, the diatoms never come back. So this thing that they tell us that it eats them, we watch them, we eat them, and then it actually you can see the problem dissipate in the tank. However, the copepods don't do work on everything. In this case, it's going to eat the diatoms off of the sand. It does nothing about the cyano. So there isn't a magic solution to all of this, and we talk about the biome redundancy and how we have to build layers of different organisms to find balance, because the ocean has them all, predators and prey and pests in our tanks. We're gonna have to figure out how to find that balance as well. Okay, so why is the solution to one problem the cause of the next? And I'm gonna tell you, like, we saw this over and over again. The hammer solution comes in and we wipe out whatever the problem is, but it's just quickly replaced with some other garbage you don't want to deal with. And it's because we're resetting the battlefield, and the next strongest organism will take over the newly created territory. So that tank, or that tank was covered in diatoms. It was taking up every available space. Well, they're all gone in a week. What, is it just gonna look good now? Like, there's some other problem that's in the tank that's going to do. And by the way, it also, that sludge, all nutrients now, right? So if I were to do this over again, I'd suck out as much of that slime as I possibly could, because it's just gonna turn into nutrients right after that. And so this is a pretty good example of this. Is you'll see a little bit of cyano on the bottom. This is gone. All of a sudden, the dinos are gone, or the diatoms are gone, but the cyano follows. So we clean it out, and the cyano stays. The diatoms never come back. But it gets worse than that. Like, it seems to be whatever the weakest organism is, just kind of follows the next one. And in general, and there's so many species of these different things, you can't really point it down to one thing. But I would tell you that it seems like dinoflagellates are the most aggressive, followed with some of the more aggressive forms of diatoms, followed with cyano, and followed with chrysophytes, and then followed probably with green, or like green algae, which is generally pretty easy to beat with a fish. But overall, the weeks here, the chrysophytes show up, and I don't know if you can see it in the screen as well, but I mean, it's just covered in this bubbly goo. It looks kind of like bubble algae, but it's matted chrysophytes. It's a colonial form. So goes from diatoms, cyano, chrysophytes, and if I wipe this out, it'd probably start something else. So the big thing here, I think, is, does anybody want to deal with this? Because I don't. And I don't want to deal with the thing that comes after it either. So what if we use a little bit of that ounce of prevention and just solved it? Like, it's hard to imagine right now. Like, what if we had just put a thing of copepods in beforehand? We would have never let the whole thing get out of control. And by copepods, you can buy them from him. You can probably go get a piece of rock from a fish store. There could be a billion different ways of doing it. So that's that ounce of prevention versus a pound of cure. The answer's obvious, man. However, action is in a calculation of awareness, risk, reward, and belief. There's a lot of things that we all believe work in our tanks, but we don't actually do them because we don't know the risks of it. If somebody had showed me that, like, hey, your tank could go this bad, and all you have to do is find some source of copepods beforehand, done. I just didn't know. I didn't know how easy the solution was. I wasn't positive and absolutely sure that this was the preventative to it. And now that I know, of course I would. But really, most preventative things in life, you have to really do that calculation that the risk is worth the reward, or the reward is worth the effort. And so in this case, monetarily. So anybody know the reason that we wiped them out in a week? It's because each one of those tanks got 16 jars of copepods. 16. It's $400 a copepod. So why did I do 16? Well, because I don't want to dose one and wait for 6 weeks and then have everybody in the room say, well, I don't know, they kind of went away because of copepods, or maybe it was time, or maybe it was whatever. I wanted a result. If 16 jars of copepods does not clear these things out, garbage, your website's wrong. But it does, right? Okay, so, but now that I know that, and I know that all the garbage that comes after of using it, wouldn't I just rather use a jar of pods up front? Because a couple of these tanks that didn't have this problem did that. And in fact, I didn't do it. I just used media that had come from a tank that had had that stuff in it at one point in time. So I'd used the pods, his ecopods, in a tank that was the donor source of rubble previously, moved into this tank. And so I didn't even need the whole jar. It's just like a couple of them existed, and they solved the problem for me later. Also, the ounce, of course, here, meaning which one of these tanks do you want? Do you want this garbage one that's full of garbage, or do you want the one that's purple and full of sponges and looks beautiful? Well, yeah, but that's week 32. Who wants to wait 32 weeks to find that? Not me. Zero. No way. I want a faster, easier way. So ounce of prevention up front, As long as I believe it's the answer, it's affordable and it's easy to do, I'd do it for sure. All right, so I answered that diversity thing. Who here thinks diversity is good? I did. Almost every forum post I've ever seen, like, oh, your tank's not diverse enough, you know, and like follow along. It just sounds like a good idea. Okay, the answer is I wouldn't chase this dragon. Like, it may be true that most advanced or stable tanks are very diverse, but I don't think this is worth chasing because I don't think you're going to achieve it. So in our diversity testing, the one that you assumed that would be the most diverse and it's the Gulf rock. You know, the Gulf rock, they dropped that rock in the ocean, let it sit there for years, scooped it up, brought it back to the facility, put it in water, packed it in water, shipped it to my facility in water. Well, yeah, I mean, that's the most live possible form of rock that you could probably have. But even that, man, is not really impressive numbers. You know, the 12th percentile, you know, 4 weeks in, meaning like 88% of tanks are more diverse than this one. In fact, almost all of these tanks, super, super low diversity. But it is true the Gulf rock won the day on all of them. But that's also this rock. Does that look diverse to you? Because it looks diverse to me. It's filled with organisms in it, not any ones I want. So diversity can be good and it can be good bad. It's just a gamble because it's not measuring only good things. It's measuring the good, the bad, and the photosynthetically ugly. However, diversity is a destination. So all of these tanks were pretty diverse. This one right here is the BRS 160. It's a 68 percentile, meaning only 30-ish% of tanks out there are more diverse than this one. This is my own tank. It's 2 years in, 8 million corals went in and out of this thing, 63. Steve's tank, 6 years old, a diversity of 72. So these are all tanks that have been up for many years. They just kind of end there. That's just the way it is when you add all these things. And diversity also measured in aquabiomics is you're only measuring the things that make up more than 1% of the whole matrix. Very difficult. However, I tried really hard to create diversity with this tank right here, which is in the BRStv video set. What we did is we went over here and we took rock, all of the rock out of this tank that has been up for like 5 years. We took water out of that tank. We took those marine pure bio bricks out of like a bunch of different tanks. Like if you were going to, and then we filled it with coral too. Like if you were going to try to create diversity day one, man, I think it'd be difficult to beat this. But it's still only a 16, right? It's just in flux. Doesn't matter what happens. You can take the most stable tank known to man, but once you move it and change the sand, all kinds of things will start to beat each other out. Okay, next one. Is sterile rock better than live rock? Raise your hand if you like live rock. Live wet rock is your way to go. Only hand. Who likes dry rock? More. All right, answer is I believe we can do better than both. We can probably find a middle ground in between because they both can have problems. So we're just swapping problems between this. Dry rock, this is dry rock here. This is week 14. So 14 weeks, we've been lighting it for like 9 weeks, pounding it with the heat of the sun, 350 par. Looks pretty clean, right? But, it hasn't had to deal with algae and dinos and diatoms because it was sterile, right? Like we haven't introduced these things. So how do we know if it's ever going to beat them? And the answer is it will beat some, but not all. And it's just a gamble. So this is the same things, dry rock, dry sand, but in this case, we added a bunch of coral instantly. And so the biome of the coral came in with it, which ended up being all that cyano on the top that just continues to get worse. And all these little red dots. I don't know if you can see them on the screen, but this is called planaria, these little red flatworms. And if there is no predator to the flatworm, guess what happens? Yeah, there's no shortage of food. It's actually a photosynthetic organism. It also preys on literally everything. In our microscope, we can see it eating copepods. We can see it eating, it lives in every shot we have. It's in the cyano. It's in with all the copepods, the amphipods, the diatoms, the dinos, all of it. You can just see them, like they're nondescript eaters, man. So there's no natural predator for this. Why would they not take over the tank? What would prevent them? And the answer is nothing, except for maybe a wrasse. Yeah, so if I put a Halichoris wrasse in there, or a little yellow wrasse in there, all of a sudden, they're just going to sit around and they're going to eat those little guys all day long, right? So they might actually be in there, but you'd never know it, you know, especially if I put it in there in the beginning when that coral presumably only brought in 5. Now it's going to have to eat several thousand. I mean, you can't see it in this picture, but they're all over the sand, man. They're everywhere. Corals are closing up. This toadstool up on the top here, you can like literally watch them crawling over the top of it. They're everywhere. Also, though, it's a gamble on what's introduced with other surfaces. So what happened here, as you saw Steve's tank a second ago, had a grid diversity score, but it was the donor of those orange diatoms. When we took 2 cups of sand out of his tank, and we thought we would seed the biome to the tank of another tank, well, what we did is we introduced those diatoms into the tank. Also, interestingly enough, this is the only tank that actually solved its own problem over time because it did have the predator for it in there as well. But in the sand, man, when I mixed it all up, basically I buried most of them, probably killed off a bunch of them. And the reality is the copepods just don't replicate as fast as the dinos do. So explosion, but eventually this one solved it because it had the solution in the tank, it just wasn't able to keep up. So is dry rock better or worse? It's up to you. You know, dry rock, dry sand. I will say that they can probably do better than this, but we also don't have to go all the way to the other end, which is just dumping everything known to man, which we'll show you in just a second as well. Okay, so this is what I'll call, you know, wet, water wet rock. That's that rock that's shipped in water rock that you got from the fish store. Because at the fish store, you know, even if that rock wasn't like the most live thing known to man, it's in a bin that was filled with lots of rock that has been there probably for ages. Some of that stuff is going to migrate onto that. But some of it, it's really going to depend on which fish store you're at and what microorganisms were in there. But there is a heavy emphasis on herbivorous fish and cleanup crew if you're going to do this method. It has the most organics on it, it has the most critters on it, and they just came, like in the case of the Gulf rock, it came out of the ocean. It was just exposed to the sun. All of that stuff is there. It's ready to take off, and it certainly does. There's also a ton of organics on this rock. So the organics that will break down, there's sponges on there, filter feeders, all kinds of different organisms that aren't going to make it in this tank. And they're immediately going to turn into nitrogen and phosphorus. The nitrogen and phosphorus is going to feed all of that green hair algae rapidly. Again, why the emphasis on herbivorous fish and cleanup crew. So this can be done, but the level of experience or skill will influence the outcome. If you just said, I use live rock and you hope for the best, well, that doesn't really, you know, that doesn't really dictate like how many of us did it differently. Did we think about the fish? Did we think about all the other stuff beforehand? And when it goes good, man, it goes awesome. It looks like that. It looks like it's covered in, I mean, who wants live rock that's covered in sponges and stuff day one in purple? You know, me, right? I definitely want that. Okay, wet water will come with the good. Microbiome, microcrustacean, coralline algae. It'll also come with the bad, which is organics and nutrients, and it'll come with the ugly. But handled right, it can actually deal with the ugly, just not if you treat them all the same. It also has a high price tag and a difficult hunt. So if you're gonna choose this path, get prepared to pay 20 bucks a pound for it. Do the math on what 100 pounds costs. All right, there's also paper wet. So paper wet is what like most of us were using back in the day. You know, you bought what you called live rock, you know, but here's the deal. It came in a box and the water was, or the rock was moist, but it was wrapped in a paper in a different language. It was not wrapped in the Wall Street Journal. It was wrapped in paper in Indonesia or Fiji, which means it was wrapped there, right? So this thing has been traveling on a boat, sometimes a plane, and it's probably been out of the water for weeks to months. So what are the chances that something like a copepod that is mobile and needs to like hunt down prey is likely to survive just a moist surface and like trying to like scrape its way around, you know? Probably pretty unlikely. And that's why when we use the Indonesian live rock, it didn't come with the copepods that would solve this, but the wet rock did. So the Gulf rock, one of the rocks that beat the diatom slurry that we put into the tank. This is the livest possible form, came from the ocean. Ocean has everything, not surprised that it worked. But the wet rock did not. So success is dependent on sourcing and handling. Who knows, you might have gotten some stuff that was 3 weeks old, it could have been 3 months old. It's less diverse source of microcrustaceans. Lots of pods are not likely to make it. It often has a less stable biome. It probably has a lot of the bacteria that you would want, but it doesn't necessarily have all of them in like ratio to the way that they should be. And some of the bad ones are winning because being wrapped in newspaper ain't the ocean and ain't a reef tank. And often has fewer organics than the wet water rock because they scrubbed all the sponges and stuff off of it because they know full well it would decay if it was sitting that way. Again, level of experience or skill will influence this outcome. So in that spirit, I'll say that it's a way. You could do it this way. It just wouldn't be the way that I would pick. I wouldn't use that rock that way without dark curing it. So I would want to get rid of the photosynthetics. I'd probably want to reseed some copepods in some manner and get it ready for my tank. All right. So the question is then, can we seed the microbiome and the crustaceans cleanly? Can we go ahead and add all the beneficial bacteria and archaea and microcrustaceans without adding all of those uglies? Right? Some of those uglies are going to come, no question. But we don't necessarily have to get the worst ones. And so the answer is, I believe yes. We're going to find out. There's a little bit more exploration that's needed here, but I think you're going to see some healthy details. So one of them is biome in a bag. Does anybody believe in reef mud? Ah, there's one. There's one. There's one. I didn't believe. This sent off my reef snake oil like crazy, man. I never, ever wanted to dose reef mud to my tank. However, in 2 weeks, the biome here has gone up to a 70 percentile in just 4 weeks, rather. We are able to measure the archaea that is coming into the tank. Also, the ocean direct as well is also above 50%. It did way better. For a reference point, the control at a 3% balance at this point. The control of dry rock and dry sand is not working at all. So these things are actually adding it, and more interesting, it's actually adding what you would think is, these are the little bands of the archaea that it's adding. That bottom one, the orange one, is called Rhodobacter acaea. Okay, this is the type of bacteria that forms as biofilm on the rock surface. So not surprisingly, that it's showing large amounts of Rhodobacter acaea on the ones that seeded it from the ocean direct and the life source reef mud. These are both substrates of the ocean, substrates that have bacteria that live on them. We're donating them to the tank. But also we can obviously add, and by the way, those two the ocean direct and the life source stuff, the life source comes in a little like Mylar type bag. No light's getting in that guy. So no to the photosynthetics are coming in that mud with it, right? No is a strong word, but very little. And so also the ocean direct, clear bag. But if you see it in the warehouse, it's packed in a cardboard box. So also a way of adding the archaea and bacteria without adding all of the photosynthetics to the tank, at least to a great degree. Same thing with the ecopods. Now, if I went to a fish store or an average place to buy some live rock out of it, I'm going to get it all. If I go pluck out a rock or some rubble, I'm going to get everything that was in there. Well, here I could choose a clean source, which is just these pods. I don't know the answer of how these things will work together. We're doing more experiments, and we will find out the answer. The other part of it is dark curing rock. So people often call this like cooking or whatnot, but what we're going to take is take the rock and we're going to put it in a dark area, let the photosynthetics die, let some of the stability work its way out before we put it in the tank. And I'll tell you, that was actually the winner of the whole experiment in my mind, was the dark cured media. It's a little unstable because the media really depends on where the media came from, but in the end, produced the best results. So the answer is, or the next question is, dark curing the rock worth the effort? Has anybody here dark cured rock before, cooked it? Okay. Did you think it was worth the effort? Yes? Yeah, okay, the answer for me, I would never use live rock again without dark curing at this point. I don't want any of those photosynthetics. I don't want any of the things that thrive off light in the tank. And yes, some of them will make it. Some will go into a dormant stage. Some of them will, weaken, whatever. But I would take these live rocks, especially that golf rock that had a lot of really beneficial things in it. I put it in a bin, put it in the tank, and let it work its way out. Okay, so what is it? It's often called cooking, but I honestly hate that term because people actually think that you're going to go cook it in the oven or you're going to boil it, and you never want to boil anything from your reef tank because it will aerosolize poisons in your face. So don't do that, okay? So for me, I want to call it dark curing because the first thing is I'm curing the rock. I'm going to let all the organics decay. So on a live rock, I want to let all the organics decay outside of my tank so I don't have a constant feed of nutrients feeding the algae into the tank when I'm starting the brand new tank, when it's most vulnerable. I don't want that feeding the tank. The dark curing, the dark part of it, is I'm going to starve out the photosynthetic pests. So the diatoms, the dinos, and the green algae and the chrysophytes, I'm going to try to starve as many of those out. Some of them are capable of going after detritus and living in different formats, but I'm not going to start with the most I possibly can, right? There'll be just segments of them or cysted forms of them or just weakened forms of them. Well, I can build up the population of predators that are going to go after them. Curing in the sump of a live system is a hybrid approach. You get most of the beneficials in that case, but you have less of the bad or ugly. This is what I did with the rubble, and one of the best methods for me, but doing that with a whole tanks worth of rock is pretty difficult. In fact, this is what Worldwide Corals had shared with me as their preferred method for their tanks, is they go and take a bunch of rock, throw it in the sump of an established system, let it sit in there for 4 months, and then they use it for the next tank. Okay, but it's important to know it was in a live system, getting all the benefits of a live system. It's got flow going through it, and it's in the dark. It's not, they just throw it in the tank and let the photosynthetics run rampant. However, who's got a sump that they can add live rock into it, an existing tank enough to start and establish a new tank? Okay. A couple of us. But I mean, not many of us have that available to start a brand new tank, so not really realistic. So I don't think it actually has to be 100% of the rock. In fact, the one that did this the best, all we did is in my sump down there, there was just a little basket of rock that I was going to use for frag plugs at one point in time. And they just sat down there. And then during the experiment, I'm like, oh, I wonder if this stuff would actually work good for this. And so in the E170, in the experiment tank, we took this stuff and put it in the little compartment in the back. And lo and behold, man, it did really, really well. It was also one of the tanks that beat the diatoms without ever adding any pods, because Sean at Algae Barn sent me pods for when I was dealing with all that crap from before. In the beginning here, we told you how hard my job was. Well, you know what? I wish I'd damn put those things in the first place. All right, so does coral dipping affect biome cycle? Anybody believe that dipping a coral will affect the outcome of your tank? Have you ever thought about it that way? Because I didn't. I never really thought about whether or not, I know I want to get rid of the uglies, but am I getting rid of the good and the bad and whatever? And what type of uglies? And the answer is absolutely it will affect it. Will it affect it bad or good? Depends on how you want to approach it. Okay, there's a bunch of different dips. I don't think most of us actually think about it in terms of this. So most of us are just thinking, I dip. But for what and why? What am I doing? So there's a bunch of them out there that are like tea tree oil and clove oil and all kinds of different oils. These are your standard array of dips. It may actually kill some pests. Certainly it's not going to kill the eggs that are on there, but most of what it does is just irritates them and they fall off, But if you look in the dish, you'll find flatworms, you'll find nudies, you'll find all kinds of different stuff, but you'll also see you don't see copepods because they're too small. But you'll see amphipods, you'll see flatworms, you'll see the good, the bad, and the ugly falling off of this thing because it's kind of indiscriminate. Well, there's another type of dip called hydrogen peroxide. Kills algae. Who here has ever done a coral dip in hydrogen peroxide? Yeah, I do. not on every coral. And we're going to find out which corals it works on. We just started the experiment last week, and we did it on Euphyllia, or hammers. We did it on acans, and we did it on zoanthids. And all of them survived a 100% strength dip of hydrogen peroxide. And what hydrogen peroxide will do is it will kill the algae. So now, instead of just putting a coral in there and hoping that I don't add new algae to it, I'm going to wipe those things off the surface of this thing almost for sure. Some will eventually make it through, but I don't need every damn species of green algae in my tank. I want it as few as possible. Even if I have good predators, I still don't want Bryopsis in the tank. Also, it will kill cyano, it'll kill flatworms, it'll kill pods, and a lot more. And it's two things. First, hydrogen peroxide is a super heavy oxidant. The other thing is the osmotic shock, because it's water in there. It's just water. And so you are mixing the coral dip between a like a poison of oxidant, and you're going from a normal salinity all the way down to 0, and it breaks the fragile cells. So super. I don't know exactly how many different corals this is applicable to, but to be frank, even with some fragile ones, I might consider painting it. I might consider, like, if it doesn't do well with an acro, how can I squirt it on there? In fact, you see that little spray bottle in there? I've had tanks where they were riddled and overwhelmed with Bryopsis, and at the time we didn't have like the same pesticides and stuff for it. So we drain the tank all the way to the bottom, just spray it with hydrogen peroxide, fill it back up, tomorrow it's gone. It works that well. It doesn't even have to soak there for more than just a couple of minutes. Also, iodine. This is an antiseptic, bacterial infections, damaged tissues, and brown jelly. So you don't think of brown jelly many times as something I don't want to introduce to the tank. And it's not well known like what causes brown jelly. And for those of you who don't know, brown jelly, it can be a really big problem if you're a Euphyllia fan. Very expensive problem. Okay, and we don't really know whether or not it's a tiny microcrustacean that actually is doing this, or a single-celled protozoan, or if it's a bacterial infection. Because it could very easily be either one of these things, and that what we're seeing with that brown jelly is actually just a secondary infection from a parasite eating it and irritating it. We don't know, but we do know is that iodine sets it back quite a bit. And my suspicion is that hydrogen peroxide, which is a stronger antiseptic in many ways, would actually probably have a similar effect on it. Now, I don't know if I want to take a coral that is already super stressed and you can see it brown jellying before your eyes and then want to use peroxide on that, because it probably won't make it. But if you took an otherwise healthy coral and got rid of some of the parasites or bacteria. But also, how many people have done an antibiotic bath? Man, 2 that I see. I did this for the first time the other day. So same thing, man, kills bacteria, the good and the bad. But like, if I'm going to be a Euphyllia fan, some of the things that the community is starting to explore is antibiotic baths. So we took this API, erythromycin, mixed it up to its instructions, and I did a bath for 24 hours for the Euphyllia in that water. And I don't know exactly yet how long is the right amount of time, but all of the corals made it through that. And so, like, this might be an evolution of how we consider, what do we introduce? If we started sterile, but added the beneficial archaea and bacteria via like sources like the life source from aquaforest or the Carib Sea sand and some pods, well, I'm still going to add stuff with coral. I know I'm gonna, but man, let's limit the amount of these things. And the one I'm probably the most excited to explore is hydrogen peroxide. And by the way, I've had a couple of talks now with some of the coral farmers of the world, and they all tell you that they go through peroxide by the gallon. One of them told me last night that they're actually exploring a way to make their own hydrogen peroxide with some machine, because they go through so much of it that it's actually expensive. Yet only a couple people raise their hand for this in this room. What can we learn from that? Okay. So what does a good biome cycle look like? So if I won this day, how would I do this and how would it look good? Well, the answer is, I think that it embraces the fact that pests will make its way into this tank. We're never going to avoid them all. That's a fairy tale. But it has the ability to solve them without human intervention, right? So this tank you're going to see is not perfect. A lot of people probably would say, oh, well, that thing had some problems along the way, and you'd be right. But they solved all of them along the way with not only no human intervention, but no crabs, no snails, no utilitarian fish, only 2 cleanings throughout the entire thing of 6 months. 10% water changes weekly was the only thing we did because you should still maintain the tanks. But very little was done to this tank, and yet it solved its own problems. So this is that dark rubble tank. So again, came out of my sump. I put it in the back of this little chamber in the E170. Water flows over it. This is week 1. I don't think you could probably see it there, but in week 1, there's already microcrustaceans growing on the back of this tank. So there's little teeny snails already growing on the back in a single week. Not very many tanks did that. And this is just like a little bit of rubble. It's a very, very simple thing to do. All right, so this has a little bit of a journey, so you have to go along with it. But for week 1 through 4, you don't really see anything other than maybe you can start to see the white spots in the back come out more and more and more. I'm not sure if you can see it on that screen or not. Week 3, of course, it all looks the same. And then week 5, the lights come on in just a moment. Tank looks pretty clean. Hopefully you can see the white spots all over the place now. The microcrustaceans are populating this tank. The first week of diatoms come. Something comes and gets rid of them though. It's replaced with a green film algae, which then in the next week is gone on its own, which then turns into, let's see what comes up next. It actually stays clean for just a little bit, but I think that we're going to see the cyano show up. So the cyano starts to show up in the sand now. All right, you can see it over here, starts to get so stringy. You can see it all over the place. But in a couple of weeks, the cyano just goes away on its own. It's gone, man. Okay, this is at week 15. In just a moment, you'll see week 15. Well, this tank looks pretty damn good. It solved all its own problems. We didn't have to get involved with it. And yes, it had some points at which it looked ugly, but like now you can see why it looked ugly and how it's capable of solving its own problems. Now we dump in all the pests. So we dump in cyano, we dump in diatoms, dinos, and all of everything ugly you can think of. And you know what? A few weeks, the one that wins is the dinoflagellates on the bottom of the tank, right? But dinoflagellates, a couple of weeks, starts to bleach out. And we didn't even touch it, and then it just goes away on its own. So it's able to solve all of these things for itself. So to me, that's what good looks like. And even though this tank did not look good at different points in it, that is the goal. If I don't want to have to use poisons. I don't want to have to starve out everything of nitrogen and phosphorus and take those old school mentalities. I want to do it better than that. Okay, so that leads into what do redundant, ugly protection look like? The answer is the tank looks awesome and prevents issues before you ever even knew there were issues. So if only somebody had told me, if you did these 5 things, you would never even run into these things. Let's do them. Okay, it's not one solution again. It's all of the solutions, and none of them are actually all that hard. So the bacteria and archaea, we're going to add those things. Bacteria and archaea, haven't proved it out yet, but I have a very strong suspicion that it's the bacteria and archaea that is going to prevent the cyano from taking over the tank. It's the microcrustaceans that we know that takes or eliminates the diatoms. Very likely a big portion of eliminating the dinoflagellates. And I have a suspicion that it might take more than just the ecopods. It might take amphipods and other things as well. Snails and crabs are also, part of it. They're scouring the surface, looking for beginnings of algae. And certain types of algae, like bubble algae, well, that's where your emerald crabs come in. I'm going to have a specific tool to a specific purpose, especially of things that are likely to come in there. Sand cleaners. Who here siphons their sand? Okay, quite a few of us. All right, I'm turning on this one. Terrence here told me a while back, he says, leave your sand alone. Right? That's where he sees the best success. In my mind, I know that the sand is the tank's litter box. It just absorbs all of the garbage in the tank and it never gets changed. And I know that because I can just go over in the back corner and spin it up and the brown turds come out of the water. It's just really easy to see. Okay, but I also know if I went and cleaned all that sand, now I know what I'm doing is I'm resetting the microbial battlefield all over the entire tank all at once. Bad idea, right? So if I'm gonna do this, let's do little bits at a time. Let's do a little corner of it. Let's divide the tank up into tenths, and once a month, man, we'll just clean the tank toilet, I guess. However, what if instead we looked at this more holistically? We looked at how do we use organisms to clean it for us? The ones that live in the ocean. Let's think about how they go in here. So now the Nassarius snail isn't just a snail with a cool little snorkel on the top that we like. It's serving a purpose. The cucumbers in there are serving a purpose. The sand-sifting fish are serving a purpose. The sand-sifting brittle stars, starfish, are serving a purpose. So if we go and add all of these things in there intentionally, can we turn over that microbiome in the sand and think about these things holistically, how they build the top of each other? And yes, some of these snails are going to die over time. You replace them because they're an important part of the ecological community. The algae eaters, everybody knows a tank, but are we going to do multiple tanks? Are we going to do like the Zebrasomus that goes after hailer algae like nobody's business? Are we going to go after bristletooth tangs like a coal tang or a whitetail tang, because those things have mouths that are designed to like scrape the surface. They'll get the beginnings of algae, but they'll also get some of the film algae as well. In fact, in my tank, you could see when I didn't have the lights on, it was eating bacteria off of the surfaces. You could see its little mouth marks all over the place, covering the whole thing. It was clearing that all out. Also good maintenance, stable and clean. So you're not just gonna let the tank go to hell. All right, so what is the number one mentality that is holding us all back, right? The one thing that I think, man, we just gotta scrub out of our DNA, and you've probably got a little bit of it already, but it's thinking that this is an aquarium or a glass box. I can't help it. This is what I did. I wanted to buy a tank. I saw an aquarium somewhere, and I thought I wanted to put some fish in it. But the reality isn't what it is. This is an ecosystem. This is a biological community of interacting organisms in their physical environment. All of the organisms interact with each other at various stages of the food web. What we're doing here is we're taking, something out of the ocean and we're placing it here in Jersey or New York, and like we're recreating this thing ground up. And for some reason, we just thought it was some fish and some coral, man. But it's so much more that's happening inside of this tank. So it's a biological community. We also tend to prioritize fish based on physical beauty rather than their contributions to the community. So this purple tilefish, this is probably one of the coolest fishes you'll ever see. Right? This is a really beautiful fish. And by the way, what you're seeing it in is under 10K light. This thing just glows in sunlight. It's so awesome. It does nothing for the tank. Jumps out is all it does. And for you're wondering if you're like, oh, I'm gonna go get one of these. Yes, the tiny little hole in the corner, it knows where it is. It'll go through. All right, but what if we thought about this in terms of the tilefish here? Let's add that aptasia eating tilefish before, because if it finds one, it'll eat them and it'll keep them at bay, right? And they're not guaranteed to do that, but there's a good likelihood of it. And so we'll keep them at bay, which means if you guys run into a problem with a ton of aptasia in your tank and you add this filefish, it's not the solution. It will never eat them faster than they regrow in the tank unless you're super duper lucky, right? It'll take a whole array of garbage you'll have to do to this tank. However, if you put this thing in first and you're only added to a new frag and it has some aptasia on it, first thing it's probably gonna do is go over to those zoanthids and snort around there and eat it, right? And it may even spread it when it's eating it, but it's gonna go look for those babies as well. And of course, in the middle one here is just the tanks. We all know the tangs eat this, so let's go after all the tangs. This wrasse here, dude, you're gonna add, the 6 lines are the meanest bastards, I heard somebody say out there, but I have added 6 lines, a halicorus wrasse. The 6 lines work, by the way. We have acro-eating flatworms in the 160, but you know why that tank thrives? It's because the 6-line wrasse lives in there. Right? We do a couple other things in that tank. We use a couple of KZ products like the flatworm stop that kind of makes the tissue stronger and less palatable. But we also, like once a month, just kind of blow them off, and they're just in there. Previously, people would have said you got aquarium flatworms, and they're like, stop buying corals, your tank's done, start it over, boo-hoo. Well, no. This tank's had them for years, man. It looks awesome. Big, huge colonies, this big. And it doesn't have to be that way. what was a 6-line wrasse cost these days? Like, $40? Like a single one of these frags is less more than $40. So in this case, man, think about this holistically, how you can go after all of these things, because you can actually have both. So like an example here, I have a tang that isn't really known for eating all that much algae. But we also have antheas, but we also have the filefish. We also have all these fish together where we can, create a system that has both the beauty in it as well as the utilitarian aspects of it. And I actually went for inverts. I went to your website again. I was surprised actually, because I was going to tell you about how some of these things eat each other. Whoops. I was going to tell you about how some of these things eat each other, but literally, you're wise enough to say, peppermint shrimp loves aptasia. Sarah snail loves algae film. Pincush urchin, hair algae destroyer. It's actually labeled for what it does, not its actual beauty. And then it says maxima clam, beautiful patterns. Miss, because the maxima clam actually clean the water. You may actually be able to skip all of your carbon and other garbage and the yellow in water, because the clam will actually filter the water for you. You should change it, cleans your water. Okay, so also the microcrustaceans, just because you see them doesn't mean they're not equally important. Hopefully we're drilling that through today, and hopefully you'll never think about the microcrustaceans in your tank the same way that when you entered this room today. But also the bacteria and archaea. Just because we don't understand the role of single-celled organisms doesn't mean they're not important. Somebody asked me today about the aquabiomics, like how valuable is this to you? And the answer is I don't know yet. I know that it was really valuable to doing an experiment. I got 12 tanks, and I'm doing it continuously, and I'm matching them up against each other. How valuable it is to a person at home, I don't know yet. I don't think it's super valuable, but the reason about this is it's kind of like ICP. Everybody said ICP in the beginning, like, why do I need to know that? This is the best possible window into the tank chemistry, and no, I don't personally need to do it all the time, but if I'm having a problem and I'm losing animals, looking into tank chemistry is the right solution. If I'm losing animals and having problems here, can I look and see, what type of bacteria and archaea are taking over my tank? And the answer is the trailblazers probably won't know. They'll be part of the team that learns something new for the rest of us. So when you're doing it right now, know that you're learning for all of us, because 10 years from now, this will be something that we can actually identify what is the right path and then replicate it very easily. Only way we won't do that is if we all put our heads in the sand and say it's not of value, which it absolutely is. Also, this is a piece of this, is habitat. Habitat is where the fish, inverts, microcrustaceans, bacteria, and archaea live. I built this NSA for me. It was the wrong move. I built this thing because I wanted to build something that was beautiful to the eye to me. And it was. I really liked negative space, and I thought it looked really great. But it didn't have a lot of habitat for the animals that I was going to put in there. So round 2, I built the HNSA, which is the habitat negative space. This thing now is designed around having as much habitat known to man. Right down here, this isn't even a piece of rock. It's tons and tons of rubble that are glued together to make a network of interchanging holes for the wrasses to live in. I thought about every place, the types of fish I'm going to have, and everywhere I'm going to have all the types of animals I'm going to have in here, and created habitat for these things to live. So when we think about the ecosystem holistically, we're likely to produce it. So, big question of the day. Should we emulate the ocean reefs or successful artificial ecosystems? And I think this is a little bit of a loaded question, because it's probably pretty obvious that it's artificial ecosystems. What we're doing in our aquariums is actually very different from the ocean. And I think the best example I can give of that is what I call the space station. So if we're going to send astronauts into space, are we going to emulate the park outside? Or would it be the best path to go emulate the International Space Station? Somebody's actually done this before successfully and housed people up there for a decade. That is probably the right move than trying to go figure this out for the first time and figure out how to emulate the Jersey Park. Okay, because the ocean has all of the pests and predators. We only have what we deliberately or accidentally introduced into this thing. So when you look at the bottom floor of this core or this ocean, you can see, like, you can just imagine how many little bugs are living in there. All of them, man. All the dinos, all the algae, all the cyanide, all of them are down in there. but they're not taking over because they're all in balance with the predators that are in there with it as well. Also, difference between an artificial ecosystem and the ocean is most ocean reefs are pristine, stable environments, and most reef tanks are comparatively dirty and unstable. Just is what it is. Like if you have an ocean reef that is like diluted by the entire ocean and the waves that are coming in, unless it's some kind of a weird little lagoon that just collects all the garbage, this is a pristine, super low nutrient, high prey environment. In our aquariums, it's actually the opposite. In many cases, it's high nutrient levels, low prey. Like we don't have enough of the little bugs and plankton and everything in the tank, and we kind of the corals kind of compensate for that by scavenging nitrogen and phosphorus out of the water. So in the end, an ocean reef is also self-sustaining. If humans got out of the way, ocean reef got any problems? Nah, well, maybe some fish, starfish and stuff, but they'll always make it in the end. It's actually us that's messing it up. But in a tank, a reef tank is an artificial ecosystem where human-made structures, which are human-made structures where organisms and an artificial environment are made to interact with each other for survival. It's not self-sustaining. It will perish without human help, and the quality of that help actually dictates the success rates of the tank or that artificial ecosystem. All right. So what's the number one most important takeaway from this whole thing? If it all wraps it up together. The answer is a proactive path of avoiding problems altogether makes reefing more fun. We're more successful and it saves money and protects the animals. I've been watching forums, I've been watching videos, I've been part of it, but we've all spent so much time trying to hammer solutions, waiting for the algae to take over the tank, waiting for the Aptasia to take over the tank, waiting for all of these photosynthetic uglies to take, and then we go to the forums and say, what do I do? Okay, should we risk aggressive diatoms now that we know? When avoiding many of the diatoms is just as simple as adding a pod population? I think the answer is pretty obvious. Some green algae are unavoidable, but peroxide dips limit the species that are introduced. And I'm not sure that peroxide is good for all of them, but let's find out. Herbivorous fish and invert predators are better preventatives than solutions to an outbreak as well. Let's put those things in before. I know algae's going in the tank. I don't have to hope and pray. I know it's in there. Let's do something beforehand. And establishing a healthy, balanced microbial biofilm may just help against cyanobacteria. I don't know that to be true. It's a strong suspicion of mine, but I'm going to find out. And this time next year, we will know. Hopefully some of you guys will try this stuff on your own and share as well. Establishing that healthy microbiome may be simple as well. Proactive reefing. Antiseptics like hydrogen peroxide, iodine can slow the growth or weaken or kill undesirable organisms like brown jelly. It may be possible that other antibiotics are helpful. So proactive treatment. Instead of waiting to watch all my Euphilia die in my tank and watch them all get infected with stuff, let's try to prevent that thing from getting in the tank to begin with. Flatworms, high percentage pests, a lot of reefers. Maybe we can get them with dips. Maybe we should just add the yellow chorus wrasse because that is a really inexpensive fish. It's actually pretty beautiful. Might as well add them in there. Aptasia, put a lid on by the way. Aptasia, introduction with LPS, super high. I mean, how many people have seen Aptasia in their zoanthids? Like everyone, man. Like every single one I see, it's in there. So super, super high. Let's just accept that and put the predator in beforehand. So if you also believe that a proactive ecosystem is a better path than a reactive aquarium, it's our collective counsel that will change the future for everyone that follows. We need to decide that we want a different world and that we're all going to share it. I like this quote from Dr. Seuss. Unless someone like you cares a whole awful lot, nothing is going to get better. It's not. And the Lorax would tell you, I am the Lorax. I speak for the corals. I speak for the corals because the corals have no tongues. It's true. Right? So it's on us to decide that we want to start living in a proactive world, that we can prevent these things, and all the people that come after us will have a better result than us. And when you set up your other tank, your 360-gallon tank that I just set up won't go the way that I had it. And yeah, guess what? There'll be haters. There'll be doubters. There'll be non-believers. And there'll be you that are proving them wrong. This is the right path. I know it. And we're stewards of all the magic here. Everybody in here that takes care of all of these corals, We're champions of progress. There's a fact that you came to this thing and sat through, I don't know how long it was now, hour and 15 minutes. You sat through this whole thing because you're the champion of progress. And everybody in this room cares a whole awful lot. Thank you. If anybody has questions, just come on up.